I'd like to start out with one of the simplest transposition cipher types, Railfence. While many online resources state that Railfence has been in use for several centuries and had been used by both sides of the American Civil War, I'm having difficulty finding any actual example usage cases. If you know of any historical examples where Railfence was used, please leave them in the comments below. Let's rejoin in the training room. Ah, good, you're here. Railfence most likely got its name from the lines used in the encryption and decryption steps. Starting with encryption, first decide on the message you want to send. Example, Railfence uses transposition. Next, pick the number of rails to use, between 2 and 1/2 the message length. Anything more than half the length will leave much of your text readable. The black chamber routinely uses between 3 and 10. We can also use an offset, which we'll call 0 for right now. Let's use 4 rails. Draw out a zigzag as shown here. Write your message in the zigzag 1 letter apiece. Take the letters off in rows, from left to right, top to bottom. This gives us RNSPO, AECETSOIN, IFESRNST, LUAI. Historically, when encrypted messages were sent by telegraph, the operators transmitted the letters in groups of 5s to reduce the chances of errors slipping in. We'll keep to this tradition. And voila, we have our finished message. Rinspo, Aset, Sowini, Fesrin, Stelua, I. Makes a lot less sense than the original plain text, which is the point. Decryption will be a little more difficult. If we know the length of the message, the number of rails, and the offset, we need to draw the blank zigzag first so we can tell how many letters we need to put on each row. It can help to have a spreadsheet pre-built for each rail width and print that out and only use the number of letter positions needed for your message length. Or create a master template on graph paper and make copies. Either way, write the cipher message in rows and read it off the zigzag. Reformatting with word spaces, we get Railfence uses transposition, which is useful because that was our original message. Solving transposition ciphers usually requires brute force. With Railfence so far, it's easy enough to write out the message for each width or rail number until you get to the correct one. But let's add a couple variations to make this a little more difficult to solve. First, offsets. Going back to our first example with 4 rails, we had an offset of 0. If we start by entering our plain text in the second letter slot using an offset of 1, for the message with offset of 1, we get this. FF WOF OOIHS TNTEE. For an offset of 2, with the message with offset of 2, we get this. OOHFT FWTFE TOISW. The range of offsets available for any given width is maximum offset is equal to 2 times the number of rails minus 3. So instead of just having 8 keys at our disposal from 3 to 10 rails, we now have the added security of the 8 widths plus 80 possible offsets total for all of the widths. The second variation is to reverse the order of the steps. Instead of writing the plain text in zigzags and taking it off in rows, we write it in rows and take it off in zigzags. This doubles our range of possible keys, which does improve our security somewhat, but also makes pencil and paper solving more tedious. Example, Railfence uses transposition. number of rails 4, offset 0. We get rurta, nakni, sayup, asle, snifs, t. Using the same message and same number of rails and offset, forward railfence and reverse railfence give us two different cryptograms. If you want to try your hand at solving railfence, I pinned a few practice scripts in the comments below. If you want to see some methods for solving railfence ciphers, you can join the Black Chamber on Patreon to get access to the next video when it comes out, or wait until it goes public on YouTube sometime later. That's enough for now. See you at the next drop point. Got questions, comments, or suggestions? Leave them in the comments below. Enjoyed this video? Then I encourage you to hit the like button and subscribe to this channel. If you want to show further support, you can join us over at the Black Chamber Patreon page, where you can get access to more how-to videos and PDFs on solving the cipher types covered here, additional crypts to solve, and more. Links pinned in the comments below. See you at the next drop point.